Hei, tässä videossa selvitetään, katoavatko polttomoottorit historiaan kokonaan vai onko olemassa tilanteita, jossa ICEt eli Internal Combustion Enginet jatkavat käytössä ja kehittyvät edelleen. Tervetuloa Vaasa Innovation Centerin tiedekanavalle, mun nimi on Sami Pöntinen. Ensiksi lyhyt historiaosuus. Nelitahtisen polttomoottorin teoreettisen periaatteen kehitti ranskalainen insinööri Alphonse de Rocas jo vuonna 1862. Ensimmäisen toimivan nelitahtisen polttomoottorin kehitti vuonna 1876 saksalainen insinööri Nikolaus Otto, ja siksi se tunnetaan nykyisinkin nimellä Otto-moottori. Dieselmoottorin kehitys puolestaan alkoi 1890-luvulla, kun saksalainen insinööri Rudolf Diesel keksi ja patentoi ensimmäisen dieselmoottorin. Dieselmoottorihan eroaa Otto-moottorista siinä, että se sytyttää polttoaineen puristuksen avulla, kun taas Otto-moottori käyttää sytytystulppaa. Dieselmoottorit ovat tehokkaita ja polttoainetaloudellisia, mikä tekee niistä houkuttelevan vaihtoehdon etenkin raskaaseen käyttöön. Ja tämä on tärkeä kohta, sillä vaikka sähköistyminen on edennyt hyvää vauhtia, on polttomoottoreille kysyntää vielä pitkään, ehkä jopa pysyvästi. Energiateknologian professori Maciej Mikulski Vaasan yliopistosta työskentelee polttomoottoreiden parissa tehden kokeellisia tutkimuksia, poltto- ja moottorimallien kehittämistä ja niiden edelleen soveltamista polttokonseptien suunnitteluun ja moottorien ohjaukseen. Hän tutkii myös vaihtoehtoisia polttoaineita.
Lower duty of operation we go, then more room for electrification. Heavier the duty, then more room for combustion engines, as simple as that. So in the future you can imagine that, I would imagine at least, automotive will go heavily electric. It's not a statement that we will only have electric cars, but majority of the energy generation in cars will come from this recovered energy, with perhaps engine as this range extender. For trucks, I think we will reach this 50-50 approach, 50% energy from combustion engines and 50% from any form of a hybridization. And this most energy density requirement is in off-road sector and in marine transportation. So obviously, bulk of the offshore transport, where you need to carry big loads over large distances, will remain combustion engine based. It's not only transport. Actually, big field that combustion engines now play a role is this overall renewable energy generation picture, and you may ask why we have solar, wind, we have hydro as renewables, but all of them are heavily discretized sources, and all of them are largely unpredictable in terms of power output. So whenever there is wind or solar, you will need to have a solution that stabilizes the energy output, and where this fast response matters, and the ability to ramp up your peak power in the order of seconds or minutes. So currently, while the renewables are booming, the market for stationary power generation combustion engines is also booming.
Ja jos kuvittelit, että uusien polttoaineiden ja moottorien kehittäminen on yksinkertaista, niin ei, sitä se ei ole.
How it's supposed to happen is together. That's the route for this coordinated route is always the most optimal route. For different reasons, currently this fuel and engine development, they don't go hand in hand. So we are considering those arbitrary fuel alternatives for a couple of reasons. Simplicity in handling the value chains of the fuels, and also from the perspective of this legislation. However, the engine is, as a device, you can say practically it's fuel agnostic. So it can burn literally anything. And of course, depending on the combustion concept used, there will be those more efficient and less efficient combinations. So the correct route is this so-called co-optima approach, fuel and engine development together. This is a picture we are ultimately trying to create as this powertrain development community, to bring the fuel companies and engine companies together, trying to develop what is the best combination. Referring to the second part of your question, so you asked how those sustainable fuels affect the development of combustion engines. Of course, they pose a challenge for development. So because I stated just a second ago, it's not a problem to burn any fuel in the laboratory. It's a problem how to burn it in such a way to meet those real-world requirements under constraints and of efficiency and emission limits. So this is the real challenge. Every time the factor changes, you have to take into account that contemporary engine now have around 14 independent control parameters. So if you would like to search for the optimum in this space, 14 calibration parameters, it's 14 to the order of 14 combinations, and that bears down to trillions of years of experimental testing if you would like to find this optimal calibration in conventional testing methodology. So I would say the main challenge that new fuels pose are related to solving this complexity issue. So as soon as we can solve complexity, then we can deal with any fuel.
No mutta entäs tekoäly, AI? Sehän ratkaisee yleensä kaiken, miksei siis tätäkin?
To a certain degree, I would have to say that in powertrain development, we have used artificial neural network modeling approaches in the 80s. So this is for us, this is old stuff, and actually not the main route for solving the problem, because those machine learning methods based on the assumption that you have a lot of experimental data and you can optimize based on that. But if we come back to this complexity problem, you need to develop this combustion concept from scratch. You have to imagine you first have to generate this data, and again trillions of years to combination. So, and we don't have this trillion of years. So actually the main focus, as I would say, regarding simulation methods currently lies on developing fast yet predictive, that means physics-based models. And of course, artificial neural networks and other machine learning methods play a very important role in optimizing, so helping to run those predictive models in still an efficient way. So.
Nykyään polttomoottoreiden kehitys keskittyy entistä tehokkaampiin ja ympäristöystävällisempiin ratkaisuihin. Uusien polttoaineiden, kuten biodiesel, synteettisen dieselin ja maakaasun käyttö auttaa vähentämään päästöjä ja vähentää riippumuutta näistä perinteisistä fossiilisista polttoaineista. Lisäksi moottoriteknologian jatkuva parantaminen mahdollistaa paremman polttoainetaloudellisuuden ja alhaisemmat päästöt. Mutta onko dieselvoiman maine saastuttajana siis oikea?
The picture is largely biased. Of course, currently we don't have on a market a zero emission, a truly zero emission concept, but it depends whether you're considering these emissions locally or globally. So electrification, if considered globally, currently is also not a zero emission concept. The emission is there because this energy has to be produced somewhere. But referring explicitly to this level of pollutants, modern diesel engines working close to this Euro stage, Euro 6 level heavy duty trucks. The output, tailpipe output is cleaner than, for instance, the air quality in Shanghai. So you can imagine that a modern truck actually driving through really heavy urban areas actually cleans the air, does not pollute. So that's the picture-wise level of pollution we are currently reaching in standard diesel technology together with after treatment. But of course those novel combustion concepts and novel fuels that are under development further are capable to cut down engine out emissions close to the near zero level.
Paine ilmastonmuutoksen hillitsemiseksi ja tiukemmat ympäristömääräykset ovat johtaneet siihen, että monet laivan varustamot ja voimalaitoksetkin etsivät vaihtoehtoisia energialähteitä. Aurinko, tuuli, ydinvoimaa. Ja tietenkin tämä myös johtaa siihen, että polttomoottorit ainakin osittain korvautuvat tai ovat korvautumassa tai ainakin vähintään saamassa rinnalleen uusia teknologioita, vaikkakin etenkin näillä dieselmoottoreilla on edelleen tärkeä rooli monissa teollisuuden ja merenkulun sovelluksissa, kuten sanottua. Ja tietysti on hyvä muistaa, että sähköistymis- tai ekologisuuskehitys etenee maailmalla hyvin eri tahtiin, riippuu vähän siitä, mistä näkökulmasta asiaa katsotaan.
I would have to say that there will not be a single solution for every domain if we consider this geographically distributed requirements and domain distributed requirements. And also, if you consider those standard fuel categories, definitely there won't be enough of the feedstock to provide a single fuel concept. So I would say that as engine or powertrains community, we are mainly looking in the direction of multi-fuel operation to accommodate as efficiently and as flexibly as possible different fuel combinations, both as standalone and in blends. If you ask me about certain black horses to bet on, I would say currently, of course, we are trying to accommodate hydrogen as much as possible. Methanol is very promising fuel. Ammonia is considered, but has many challenges. But as I said, you have to consider this from the perspective of a paying customer. Those fuels that I mentioned, they will be expensive. And we often tend to narrow down our perspective to these well-developed countries where we live in Europe, that we are able to spend our money for those clean fuel solutions. But majority of the world doesn't live under those constraints. So those countries, those regions and those domains that actually feed us, that our food prices and the whole economy relies, they will have to rely on cheaper solutions. And to this end, a very important direction is developing so-called diesel-like drop-in alternatives. And in this direction, mainly waste-derived fuels are researched.
Intialaisen talousanalyysiä tekevän Arankan mukaan maailman polttomoottorimarkkinoiden arvo oli vuonna 2021 vajaa 60 000 miljardia dollaria. Ja arvion mukaan sen ennustetaan nousevan 93 615 miljardiin vuoteen 2029 mennessä. Kasvu on siis valtava. Ja se todennäköisesti laajenee edelleen henkilö- ja hyötyajoneuvojen kysynnän kasvaessa sekä vakiintuneilla että kehittyvillä markkinoilla. Sähköisiä voimansiirtoja myös yhdistetään yhä useammin tämmöisten ICE:den kanssa ajoneuvojen polttoainetehokkuuden parantamiseksi, mikä myöskin edistää alan kehitystä. Ja lisäksi polttomoottoreiden ICE:n kysyntä kasvaa eksponentiaalisesti sellaisilla toimialoilla kuten maatalous, rakentaminen, kaivosteollisuus ja sähkön tuotanto. Vaikka uusien energiateknologioiden kehitys on luonut paineita polttomoottoreiden vähentämiseen, niin niiden jatkuva parantaminen on myöskin auttanut niitä sopeutumaan muuttuviin ympäristö- ja energiavaatimuksiin. Ja tällaiselle osaamiselle on edelleen kysyntää.
To understand what knowledge is valued to develop powertrains or combustion engines, you have to realize that combustion engine itself is a very multidisciplinary field. So as you mentioned, you have fuels, so you have chemistry, chemical kinetics, often plasma physics regions in those very advanced combustion concepts. Then you have mechanical issues and connected with, you still have to interface with this powertrain, so you have electrical energy transition somewhere in the background. Catalysts on top of that, waste heat recovery. So combination of mechanical thermal knowledge and throughout knowledge on control is the essence. I would say we are trying to educate and ultimately trying to bring those people on the market that have this multidisciplinary expertise, and that makes them also very attractive to the other sectors because they can think out of the very narrow own domain. So that is crucial. That is also one big part of the challenge to get the right people on the job. It's difficult, but it's also fun therefore.
Lopuksi päästään vielä kurkistamaan siihen, että mitä esimerkiksi Vaasan yliopiston Vebic-laboratoriossa tällä hetkellä tutkitaan polttomoottoreihin ja polttoaineisiin liittyen. Siellä on hyvin mielenkiintoisia ratkaisuja tutkittavana ja etenkin tämä viimeinen radikaali lähestymistapa kuulostaa aika jännältä.
Regarding those concepts or projects of particular interest now, at our university we are focusing on one side on this low temperature combustion technology. We call it RCCI. That's an abbreviation for reactivity controlled compression ignition. So it's a dual fuel concept in principle that relies on a small amount of high reactivity fuel like diesel to ignite the mixture, but the main power comes from largely premixed placed in the cylinder low reactivity fuel like natural gas, methane, biomethane, hydrogen or ammonia in fact. And the whole beauty of the concept is that it enables very high heat release rates which support superior efficiency, but at the same time this is a very lean and at the same time low temperature burning concept, and low temperature supports or suppresses nitrogen oxide emissions. One thing that we will be started, and we are approaching this RCCI concept holistically, so from developing the combustion engine technology, pairing this with the whole engine system, turbochargers, after treatment system, and also considering noise aspects, because we are mostly speaking about atmospheric emissions as constraint, but slowly it starts to give field to the noise emissions. So noise legislation is becoming this silent suppressor for advanced power generation technology, a direction definitely worth looking for. From the side of something more radical, we will be starting a project related to so-called argon power cycle. It's a radically new system where the idea is to exchange the air as a working fluid in the engine with a monoatomic gas, and that is an enabler for true zero emission because you don't have exhaust at all, you recirculate argon, you run it in closed loop. But that's only kind of a cherry on top. The true motivator is this superior efficiency. With argon power cycle, we are hoping to achieve this 70% efficiency.
Toivottavasti pidit tästä videosta ja sisältö oli mielenkiintoista. Ehkä sait jotain uutta tietoakin samalla. Jos haluat lisää Vic Science Channel-videoita, niin voit kannustaa meitä jatkamaan tilaamalla kanavailmoitukset, kommentoimalla, tykkäämällä ja jakamalla sisältöjä myöskin eteenpäin toisille kiinnostuneille. Kiitos katsomista siis vielä kerran ja palataan seuraavassa videossa.